Welcome to DevOps Corner.
All right, let's talk about one of the most maddening problems you can face in AWS, the silent failure. The kind of thing that makes you want to flip a table because you know something's wrong, but you just can't see it.
You know this screen. Oh, you know this feeling. Your app is down, users are sending frantic messages, and you are staring at this exact error. But here's the kicker. Every single one of your dashboards is glowing green. The instance is healthy, the load balancer says, I'm good, and yet your traffic is just vanishing. It's a silent block, and it's beyond frustrating. So what's the culprit behind this chaos? Well, 9 times out of 10, it's these two right here, Security Groups and Network ACLs. They look kind of the same, they both act like firewalls, but trust me, they behave in completely different ways. And getting that difference wrong, well, that's the recipe for these silent, soul-crushing failures. Okay, so let's build this out so it makes sense, starting from the inside. First up, the security group. The best way to think about this, it's like a personal bodyguard for your EC2 instance. I mean, it's standing right at the virtual door, and its entire job is to protect that one single resource. Now, look closely at the rules here. See what's missing? There are only allow rules. You can't create a deny rule in a security group. It's basically a VIP guest list. If you're on the list for port 80, you get in. If you're not on any list, you're just not getting in. And importantly, the bodyguard looks at the entire list all at once to decide if you're cool. Okay, we've got our bodyguard at the instance door. Now let's zoom out. The next layer is the network ACL, or NAC for short. This is totally different. It's not a personal bodyguard. It's more like a strict border checkpoint for the entire subnet, the whole network neighborhood your instance lives in. It checks your papers before you even get on the same street. And right here, you can see how different this thing is. First, check out the rule numbers. NACLs go through these rules in order, from lowest to highest. The first rule that matches wins. Game over. Second, look, you can explicitly deny traffic. This isn't a friendly guest list anymore. This is a strict set of laws. And honestly, this is where things go wrong for so many people. Okay, so we've got our 2 layers of security set up. Now, let's play detective. Let's get back to our original mystery and trace a single packet from the user all the way in and then all the way back out. We're going to find out exactly where it's disappearing. So here's the inbound journey. 2 stops. First, the packet has to get through that tough border checkpoint, the NACL. If it makes it past, it then has to get past the instance's personal bodyguard, the security group. Okay, here comes the request packet. It hits the subnet border, the NACL starts checking its list. Rule 100, allow HTTP traffic. Bam, we have a match. The NACL doesn't even look at the other rules. It just says, you're good, and lets the packet right through. So far, so good. All right, the packet made it to the instance's front door. The personal bodyguard, our security group, looks at its VIP list, sees HTTP traffic is on there. Perfect. The door is open, and the request gets to our application. At this point, everything looks like it's working perfectly. So, our application does its thing, it processes the request, builds the web page, and sends that response packet back out on its way to the user. And right about now is when our silent failure happens. Okay, this is the most important concept to get. Security groups are stateful. What does that mean? It means they have a memory. That smart bodyguard remembers the request it just allowed in, so when it sees the response packet leaving, it recognizes it. It's like, oh yeah, you're the reply to that conversation I just okayed. Go on ahead. It doesn't even need to check the outbound rules. So wait a minute. This is the core of the mystery. The bodyguard let the response packet leave. It's out of the instance, so why is the user still staring at a connection timed out error? Where in the world did that packet go? And here it is. This is the answer. NACLs are stateless. Unlike our smart bodyguard, the border checkpoint is completely forgetful. It has absolutely no memory of the packet it just allowed in a millisecond ago. To the NACL, this response packet is a totally new event, which means it has to check the outbound rulebook from page 1. And here's our smoking gun. We look at the outbound rules, and there is no explicit rule allowing the return traffic on those high-numbered, temporary ports that web clients use. So the NACL checks its list, finds no match, and what happens? It hits that very last rule, the asterisk, which is a deny. And poof, the packet is dropped, silently. No warning, no alert, it just disappears. This is the silent failure. So let's just hammer this home one more time because it's that important. Security groups are stateful, they remember. NACLs are stateless, they forget. The smart bodyguard with a memory versus the strict border guard who asks for your papers every single time. If you can get this one concept down, I promise you, you can solve 90% of these weird AWS network problems.
Okay, here it is. The ultimate cheat sheet. Everything we just talked about, side by side. Scope, instance level versus the whole subnet. Rules, security groups only allow, while NACLs can allow and deny. State, stateful versus stateless, the big one. And evaluation, all at once for the security group, but in strict numerical order for the NACL. Seriously, screenshot this. It'll save you a headache later.
So the big question is, when do you use which one? The answer is actually pretty simple. You will always use security groups. They're your primary defense, your go-to for controlling exactly what talks to your instances. Now, NACLs, think of them as an optional extra layer. They're like a sledgehammer. They're great for big, broad actions, like blocking a known malicious IP address at the subnet level before it can even get close to your stuff.
So if you only remember one thing from all of this, let it be this simple phrase. Security groups are smart, NACLs are strict. They're not enemies, they're just different tools for different jobs. Use the smart bodyguard for detail protection and the strict border guard for broad enforcement. Get that right, and you can say goodbye to those silent, frustrating connection timeouts for good.
Thanks so much for joining us on DevOps Corner. If you enjoyed this deep dive and it helped things click for you, be sure to hit that like button and subscribe for more explainers that break down how modern infrastructure really works.